is by and large one of the most important topics, simply because of the fact that a lot of problems are based on percentage. The whole business world runs on percentage. Data interpretation almost completely runs on percentage. So this is a pretty important chapter. And this is one chapter where there are various approaches that are used, a lot of shortcuts that are talked about. But what we'll do today is we will work on the fundamentals like what we have been doing till now. And then we'll try and solve some problems from level 1 and level 2. And then level 3 and level 4, we will do it in the next session. Right. So percentage, I'll not get into the basic definitions. I'll talk about one area where a lot of people can make mistakes. Let's assume that there are two people, A and B. Okay. So A has got, let's say, 100 marks, let's say 100 marks, and B has got 80 marks. Now, the first question is, how much marks has B got less than A? So by what B has got how much marks less than A? B has got 20 marks less than A. But suppose I ask in terms of percentage. By what percentage is B less than A? Right? And the other question is, by what percentage is A more than B? The question is by what percentage? Okay, by what percentage? Percentage by B, by percentage by which A is more than B and B is less than A. So this is something which is very, very important for people who are starting off with percentages. In both cases, numerator is 20. Okay, both cases numerator is 20, which means in terms of marks, B is 20 marks less than A and A is actually 20 marks more than B. So this much is okay. But then the denominator changes. Here you're comparing with respect to A. Okay, by what percentage is B less than A? So you're comparing with A. A goes to denominator. You have 100 here. Okay, now this is what? 20%. Now the next question is, by what percentage is A more than B? So now the comparison is with respect to B. Though the numerator is the same, denominator changes. It becomes 80 here. Okay, so it becomes 1 by 4, which is 25%. Okay, this into 100 is there. This I think is into 100, which you multiply by 100 to get a percentage. Okay. Now, this is something which is very, very, very important. That probably is the most important thing, and you'll get questions. I mean, people get confused based on this. So here you'll find that with the same score, 10 and 100, B is actually 20% less than A, while A is 25% more than B. Okay, so this is something which is very, very important. Against what are you comparing? Less than A. So A goes to denominator because you're comparing with respect to A. Here you're comparing with respect to B. So B goes to denominator. I'll stop here now. I want, who are the people of course? I want, Prakriti and Shikha to react on this. Have you understood this? The others can also react. I think.
Yes, sir. Understanding.
You understood? How about Shikha?
Yes, sir. Understood.
This is something which is very important because you shouldn't get confused because you're seeing two figures, 20 and 25%. Against what are you comparing? It is not always possible. Some of the questions could be in such a way where the comparison is given exactly. Here it is given less than A. There it is given more than B. But in some cases, it might not be given. For example, suppose I tell you suppose some figures are given, like say year 1, year 2, year 3, year 4 is given, right? Yeah, and then let's say sales is given. Okay, let's say sales is given. Sales, let's say this is what, 75. Let's say this is, let's say 90. Let's say this is 120, 100. Okay. Now the question could be, what is the percentage, say, growth percentage, or let's say, let's take interesting. Let's take a figure like 60 here. And okay, that's okay, fine. So now let's say, what is the percentage growth in year 2? So when we are saying percentage growth in year 2, the comparison question is not asked, but they're asking what is the percentage growth in year 2. So obviously we know that the percentage has to be with respect to year 1, because you're talking about a growth in year 2. So which means, what is the increase here? The increase is 15 with respect to this as a denominator, because you're talking about the percentage growth of year 2. Even though we have not talked about with respect to what, it basically, we know that it has to be the growth in second year, which has to be with respect to the previous year. So the percentage is actually difference of 15 divided by 75, which is 1/5, which is actually 20%. Okay. Now, what is the percentage drop for the third year? Percentage drop here. It's a percentage drop here, isn't it? Here's a percentage drop in the third year. So percentage drop in the third year has to be with respect to the second year. So the drop here is 30 compared to the second year. So it is, drop in the third year is 30 divided by 90 into 100, which is, 1/3. 1/3 is 33 and 1/3%. 33 and 1/3%. Right? Now, suppose I ask you another question. What is the percentage growth for the whole period? Right? The percentage growth for the whole period, I'm talking, so which means you're talking about the whole period. So you're comparing the fourth year with respect to which year? With respect to the first year, because you're talking about the whole period, right? The whole period is a difference. So this is the comparison. Comparison is this with respect to this. The difference is 75. And denominator obviously has to be again 75, because you're comparing the last year with respect to the first year. So it becomes 75 by 75 into 100, which is what? 100%. 100% growth for the whole period, which means from year 1 to year 4. So this is how you do. Sometimes the comparison might be given. Sometimes the comparison has to be inferred by you. Okay. So broadly, this is about it. We have to get, the most important thing is you'll find the difference, but then make sure that you get your denominator right. If you get your denominator wrong, your answer goes wrong. Okay. This is all there is as per percentage concern. There's nothing more. So if you are comfortable with this, then percentage is something which we can actually handle. Okay. I'll stop for the time being. Is it okay? Most of the people are okay with this?
Yes, sir.
Okay, fine. Now, another thing, now how to solve problems. Okay, so now this is something which we have to be very, very, see, there are different approaches people take. One approach which people say is you assume 100. Assume 100 and then start solving a problem. That is one approach. Okay. Assume 100. Let's say, assume 100. We'll see different kinds of problems where you assume 100 as a base and then start solving it. There's another method which is also unitary method. Okay. Right. I generally teach this method because it's quite universal and it works out extremely well. You can solve almost all problems. You can solve almost all problems. Okay. Almost all problems using this method. Okay. Right. This is also quite an interesting method, but then this does not work universally. You need to be very, very comfortable over a period of time to start using 100 as assumption. Okay. So what we will do is along the way, as we move forward, I'll teach you this method. And okay, I think I'll do that now itself. Okay, I think I'll start off with that. Let's say that you have let's say there is a person. Let's say somebody has got. Let's say Rahul has got. Let's say 70 marks. Okay, 70 marks. Okay, Now you have to increase that by 20%. I'm going increasing by 20%. Okay, right? This is what you do. So one way of doing it is, what do? You calculate 20% of 70%, which is what? How do you calculate 20%? You take 20 by 100 into 70, which is what? You get as 14 marbles. Okay, this is 14 marbles. Okay, now you add both these. So you get 70 plus 14, you add, you get 84. Okay, so this is how you go about doing it, increasing by 20% and adding it back. Now, if you really look at what you exactly have done is 70 plus 20% of 70 is how you increase it. Is that okay? Suppose I take 70 outside, what happens? I take 70 outside, I get 1 plus 20 by 100, or 20 by 100 is actually what? 0.2. So this becomes 70 into 1.2. Is that clear? I've increased something by 20%, which means I actually multiply by a value 1.2. This is the unitary method. Okay, this is the unitary method I'm talking about. I'm not talking in terms of hundreds at all. I'm only talking in terms of unity. So it means the whole base becomes 1. I multiplied this by 1.2. Now suppose I'm decreasing by 20%. Now this is it. This is it. Now I change this to a decrease. Okay, suppose I change this to a decrease. Decreasing by 20%. Now if it is decreasing, what happens? Then instead of a plus, this becomes a minus. This becomes a minus, and 70 minus 14 actually becomes 56. Okay, but here how do you do it? 70 minus 20 by 100. Sorry, 20 by 100 into 70, which is 70 into 1 minus 20 by 100, which is a 0.2 now here. This actually becomes 70 into 0.8, which you get it as 56, and 70 into 0.8 you get it as 84. Okay, right? So this is something which is a very powerful way of solving percentage problems. And then once you are able to do this, you'll find that most of the percentage problems you can solve actually using linear equations. Okay, linear equations. You can actually solve using linear equations if you have understood this whole concept. This concept. Increasing something by 20% is actually multiplying by 1 plus 0.2, which is 1.2. Decreasing something by 20% is multiplying by 0.8. Okay. Now, so now I'll just solve. I mean, are you okay with this till this point of time? This 1.2 and 1.8. Are you okay with this?
Yes, sir.
Yeah, you're okay with this now. Okay. Now,
One question.
yeah, go ahead.
So this is it fair to say like this is like a shortcut to how we would solve, right?
This
No.
is the way that you can solve almost all problems in percentage.
All
This is
questions,
one
sure.
thing that you will have to. I mean, I think for you to be good at CAT and solve problems fast, this is something which is
For fast, yeah.
100%. I mean, it's not only fast. You'll find that every percentage problem becomes very simple if you know this method.
Right. Okay.
So which means now I'll spend some time on this method. I'll probably do some calculations, and then because I want people to be thorough with this. And let me tell you one thing, especially people who are not comfortable with percentages. This initial portion I talked about, this is about 10 minutes, 15 minutes of class I'm going to spend on percentages. It would be good if you just watch that 10 minutes at least once in every 15 days for the next 2-3 months. Even if you watch it 4 or 5 times, it's okay, because you'll find this being used repeatedly every time as we move forward. Okay, this approach. And this is probably one of the most important 10 minutes of CAT. I mean, CAT maths, this is the most important 10 minutes, because this is the way I'm going to solve most problems now. And you'll find that in DI, everywhere this method becomes very powerful. Okay, now I'll just spend 5 more minutes on this, and then I will move to the problems. Okay, right. Now let's say, okay, I have X here, okay, and the same thing, X. I'm increasing X by 30%. So first thing, what X 30% means, what is it? I multiply by 1.3. Okay, Right now, let's see who are the people who have come today. Right, Arvindan should be okay with this. Prakriti, Pratik should be okay. Let's see. I think you have only Shikha. Okay. Right. So, right now, Shikha, can you put on your mic? Okay, I'll ask you questions now. Okay, just keep answering. Okay, Shikha, are you there? You guys there? Can you put on your mic? Shikha, not there. No. Okay. Fine. Right. Okay. So if I'm increasing something by 30%, it means I'm multiplying by 1.3. 35%, 1.35, multiplying by 1.35. Okay. If I'm decreasing by 30%, then what happens? 1 minus 0.3, which is 0.7, multiply by 0.7. Decreasing by 35%, 1 minus 0.35, which is you multiply by 0.65. Okay. Right. Now suppose I'm increasing something by 80%, increasing by 80%. What do I do? Okay, Prakriti, can you answer this? Increasing by 80%, what do I do? Multiply by?
Don't know, sir.
Increasing by 80%, what do I do? Increasing by 30%, what do I do? I multiply by?
1.3.
Yeah, so increasing by 80%.
So 1 plus 80 by 100.
Yeah, 1.8.
1.8, yeah.
Decreasing by 80%?
Then
1 minus 0.8, which is?
1 minus point. Okay, sir.
Which is 0.2. Okay. So
Right.
now, Prakriti, you still stick with me. Okay, I'm going to make you more uncomfortable. Increasing by, let's say, 100%. No, because you should get this right. The others, I'm quite sure most others will get it right. They would have done this. I mean, they would have understood what I'm trying to do, and they'll probably pick it up because that's the reason I'm trying to make you uncomfortable. Okay, increasing by 100%. What happens?
Into 2.
Excellent, excellent. Increasing by 100% is multiplied by 2. 100% increase. Okay, right. Great. Increasing by is multiplied by 2. Okay. Increasing by, let's say, 170%.
1.7.
2 points.
No. 2. Okay, right.
Right. Increasing by 170% means it is actually 1 plus 1.7.
1.7. Right.
Is that clear? 1
yes.
plus 1.7. Is that okay? Suppose I increase something by 950%.
So 1 plus 9.5.
Yes. Excellent.
10.5. Okay.
Yes, that's good. So this is 10.5. So which means, so now when you see a 950% increase, don't get confused. Okay, now we are getting into, and I'm increasing a value by 950%. Suppose I say the sales of company X increased by 128% the next year. So the sales of company increased by 128% the next year. I know that I should multiply the sales by how much for the next year?
1 plus 1.28.
Yeah, so it becomes
2.28.
Excellent. Right? Is that clear? Now,
yes, sir. Yeah.
Now this is all increase. Now suppose I say the sales for the next year decreased by 15%. Then what do I understand that by? Decrease by 15%. Okay. Decrease by 50%.
1 minus 0.15. So 0.85.
Excellent. You multiply by 0.8. Okay. Decrease by 99%.
Multiply by 0.1. No.
0.01.
0.01.
Excellent. Okay, fine. So I think, okay, now I'll just stop and open it for the whole class. Is there anybody who has got a problem with this? I think all of you are okay with this?
Sir, I don't have problem with this. I have problem with my mental math, but okay.
No, that's okay. That's okay. That's fine. This is fine. But still, I think more or less, if you have understood this concept, your whole percentage becomes very easy. I think
yes, sir. Understood. I have definitely understood.
Right. like I said, if you have not gone through, please go back and see this 20 minutes. Okay, this is probably pretty important. Again and again, you see, there's no harm in this. Right. So what we'll do now is we'll go back to some of the books and then try solving problems. I think most of you are comfortable with this. Now we'll go back to the books. Is there anybody who's not comfortable? I'll explain once again. Anybody? Ronak, is it okay? Ronak, you're okay?
Yes, sir.
Good.